All right. Cool. Let's get started. So go ahead and feel free if you have any Python questions to post those in. I'm going to get started on the Unpacking Lists section. Last time we talked about modifying elements and mutability, the difference between mutability and immutability. Yeah, so that was a pretty big topic by comparison to this topic, which is just unpacking lists. This is a very simple idea. It allows us to, if we have a list, you can do this with a tuple as well. If you have a list of elements or a tuple full of elements, you can break each element into its own variable, essentially. So you can assign a variable to each of the elements, and there's a sort of quick and easy way to do that. We'll look at that here. All right. So basically, it's like it's like this: man, bear, pig. Okay, a little South Park reference here. So sum list. So we can create a list, and we can assign that list to a variable. Pretty easy. Let's print that off. Not much going on here. Pretty straightforward. We can also, let's say I have a list of elements, and I want to break these down into each of their constituent elements. We'll say L, LM1, LM2, LM3. So now I'll just print element 2, which will be bare. So now what I've done here is I've assigned 3 different variables to each element in this list. And this is something that you can do with lists. You can also do this with tuples. So I just take these brackets off. Python's going to look at this. It's going to see this sort of comma separated values syntax. And it's going to be like, oh, okay, I'm just going to assume that's a tuple since it wasn't explicitly cast as a list. This is going to work exactly the same. Same thing if I put parentheses around it, I'm explicitly stating that it's a tuple, but it's either this is explicitly a tuple, this is implicitly a tuple with no brackets or parentheses. But it will work with lists as well. This tends to be something that you do more with tuples, but it is possible to do with lists. The reason you don't see it as often with lists, a list doesn't have a guaranteed size in the way that a tuple does. So let's look at that a little bit. Obviously, when I'm doing it on a line like this where I have a list literal and I'm putting in each element, like no part of the program is going to come around and change this list at the time that I'm saving it into these elements because I'm declaring it right here, which I don't need to do. So let's do this. Let's put a layer of abstraction in it. So the layer of abstraction is the variable sum list, right? So now I have that variable again. So sum list equals a list containing the 3 strings. And then I can break each of those strings into its own variable like this. So sum list still exists. It doesn't dismantle or destroy sum list in any way. Sum list still exists. Well, it's going to run eventually. And then we also have variables that point to each of those elements. So we'll print out element 2 and we can see element 2 is going to be bare. Right? So something to watch out for, like I said, you can do this with tuples. Tuples are like lists except that they're immutable. So nothing can come along and alter the tuple. you could alter the variable that holds the tuple, although that's different from altering the tuple itself, right? So let's look at something that would alter a list. If I say sum list dot append man, bear, pig, what else is good? Panda. That's kind of, panda is sort of a man, bear, pig. Cool. So what I did is I changed the size of sum list. I added panda to it. And now I get an error because if we look here, let's look at this value error. And it's going to throw this error for this line. It's going to say value error, too many values to unpack. It expected 3, right? And that's because I have 3 values. I'm saying unpack into these 3 values. So, think about it, like, how do I unpack 3 values from a list of 4 elements? You might say, oh, well, maybe the assumption should be that it's just going to unpack the first 3. But somebody else might say, well, it'll unpack the first 2 as expected, and then it'll put the other 2 in a list, right? Like you could make multiple assumptions about what it should do here. But since no one assumption is clearer or superior than another in this case, there really isn't a good, like, obvious behavior that this should have. So the safe thing to do is for Python to say, hey, you tried to unpack a list of 4 things into 3 elements. I don't know what you want me to do. So it just throws an error and says, fix your code, right? Which is nice. It's going to help us write safer, better code here. All right, so this is the reason that this is often more useful to do with or why this is usually done with a tuple instead. Unpacking elements kind of makes more sense with a tuple because tuples, let's make this a tuple. We'll just take those parentheses off. Tuples don't have an append method. They don't have any methods that will alter the tuple on the data type level, right? I could say equals hello, right? Now I could just change the type of it, which is I'm changing it from a tuple to a string. But this is different. This is not a mutation. This is just a reuse of the same variable. This will cause an error as well, but it's nice to know that this kind of error would be a mistake that I made always. If you're expecting something to be a tuple and it's not a tuple, it's because something you did, which is nice because that means you have control over that and you can do something else. With a mutable type, perhaps you do something with your list at some other point that changes it in a way that you're not aware of. You don't have a guarantee about the size of this list. At some point you can't guarantee that this list is always going to have a length of 3 unless you do something like if len sum list equals 3, which you could do, like this could be a safety, some kind of protection. But if you're using these elements outside of that condition, and the list is not of length 3, then could get kind of confusing. So you can do this with lists, although, like I said, usually you'll do it with a tuple instead. This is sort of one of the main examples of how sometimes it's better for a data type to be immutable. Sometimes it's desirable. Maybe not better, but desirable. Let's say that. Why am I lying? Okay, that went over my head. Oh, I get it. No longer over my head. Okay, never mind. Cool. So that's unpacking a list and a tuple, in short. This is talking about syntactic sugar. This is a term that we use. Sometimes a language there'll be something that's like really common, but maybe a little bit clunky. Or maybe not even a little bit clunky, but you're like, oh, since I do this thing all the time, I can make sort of a shorthand for it to make it just slightly easier or slightly better. This is what they mean by syntactic sugar. So let's look at this. So Python treats this unpacking here. I'm gonna kind of, well, I want to leave that example there. I'll slack in my notes at the end of study hall so you can reference them as well. So if we do boom, boom, boom. Okay, so this is shorthand for this, right? So lm1, 2, and 3 equals sum list. It literally is the same as doing lm1 equals sum list 0, lm2 equals sum list 1, lm3 equals sum list 2, etc. Right? So these two sort of groups are the same. So this is what we would say is syntactic sugar. It just makes it a little sweeter. It's like just makes this other thing a little easier. Not that this other thing is hard, but you know, if you had 4 or 5 things, you're just kind of adding a bunch of lines of code. You know, why not just cinch it down to 1 line of code if you wanted? So makes that process just a little better. Cool. We've got a request that I go through a certain problem. Send me a link to that, and I will go through it. Send me a link to. It looks like that's from Learn. Just put the link in. You don't have to DM it to me. Just put it in the thread there. I'm just going to do the challenges for this really quick while you're getting that link, and then I'll go through it. Write a function called list unpacker. Presumably, is it going to take in a list? Let's see. This function takes one parameter, which is a list of length 3. Okay. As an argument, the function should return 3 values from the list in the order they are found in the list. The funny thing is this function is going to return a tuple. I'm sure I could shortcut this by saying tuple list. I bet this will work. I want to demonstrate this because I can say list, or excuse me, A, B, C equals list, return A, comma B, comma C. When you return multiple things like this, Python assumes that this is a tuple. Again, this is similar to that syntax that we looked at earlier. where we have just comma separated values. Even though these aren't the values themselves, they're variables that already have values, so same thing. Cool. Is that what they, oh, the example is exactly the same as my code. That's cool. What will the Python interpreter do if you unpack a list that contains 3 objects into 4 variables? So it'll give me the opposite of the error. It'll give me an error that's just a sort of the opposite variation of the one we got. It sets the 4th variable to none. It doesn't do that. It throws an exception and halts the execution of the code. That's what it does. It assigns the first 3. Yeah. This is an interesting thing, right? Like these other 2 are valid assumptions about a behavior that Python could have. Anytime there's something like this, notice that you do make an assumption, or that you could make various assumptions, and just notice that Python will, any language will have the assumptions that the developers made for that language, and those kinds of assumptions are, thought out pretty thoroughly, and you kind of have to sort of make the decision about like, okay, what's the safest option? And you sort of start to learn to think that way, like what would be the, the safest option, give you the most predictable result. And a lot of times the best thing to do is to just throw an error, or arguably the best thing to do, Okay. In the code below, you're given a list containing 4 elements. Unpack the list as follows. The first element should be stored in the variable we are unpacking our list. Okay. We are unpacking our list equals list. Is that going to do it? I think that'll do it. Meh. Has no attribute our list. Aha. I said LST because that's my habit, and it's expecting our LIST. Okay, so just a typo. Cool. All right, I see the link that the person who's asking the question posted. Okay. And I believe this was number 3. Walk through question 3. Good. Yes. So in list iterations and enumerate. Okay. Oh, this is the alt series function. Okay, cool. So I'll pull this in. I should make a solution video for this because I get asked about this question quite frequently. You're not the only one. Okay, here's my tests. Rid of that example. And then, okay. Let's go through this. This is why I like to bring things into my text editor so I can kind of chop this up and, turn it into notes that are useful for me. So you can do the same. Write a function called alt series. The function should have one parameter, which is a list of numbers. So that's our input, a list of numbers. Okay. In a variable called alt sum, sum together all the numbers in numList where the values with even indices are added and the values with odd indices are subtracted. and a variable called powSum. Sum together are the result of raising each value to the power of its index, and then a variable called indexSum, IDXSum, sum together the result of raising each index to the power of the value at that index. So this function should return all three variables in the order AltSum, powSum, and IDXSum. So when you want to do multiple returns, you'll do this return AltSum, powSum, and IDXSum. And then let's initialize these. These are all going to be we'll just do it that way, you know, as is in line with our previous one. So we'll initialize all three of those at 0. Okay, so for this one, there's sort of a tricky thing in the notes here. Recall that in order to return multiple values from a function, you simply separate them with commas. We did that one. Let me get rid of that. So this is the tricky thing. There's this little note hidden here. The summation index should start at 1. So if this is the way this is stated is a little bit dense, but this is essentially talking about enumerate second parameter should be 1, which will tell us where the index should start. So if I say for IDX num in enumerate list, we'll start the enumeration at 1, and from here we can just treat this like a checklist. We'll do each one of these variables independently. I have these tests so I can compare the results. So I'm going to do AltSum first. If let me just throw a pass in here. So if I run this, I'm just going to get a tuple of 3 zeros. And then the first one I'm doing, like I said, is AltSum, and I should see 4 for the first test and 0 for the second test. And then obviously the rest of the tuples should be zeros as well. Okay, cool. So AltSum, what is it? Add evens and subtract odd. Okay, so in a variable called AltSum, sum together all the numbers in numList where the variables with even indices are added. Okay, the other ones are subtracted. So if the index IDX is even, which I can determine by saying if IDX over 2 has a remainder of 0. So if the remainder of IDX over 2, and I can use I can use the modulo operator. So I'll say if IDX mod 2 equals 0. Remember modulo gives me the remainder of dividing index by 2. So if index over 2 has a remainder of 0, then we will AltSum plus equals num. Else, it's either has a remainder of 2 or not. So AltSum minus equals num. And we should see that 4 there. There we go. So 4 and 0 in my first place. So that appears to be working, at least according to these 2 simple tests. Let's just look at what happens if I don't start the enumeration index at 1 there. I'm actually going to get -4. So I'm going to be adding the ones I'm supposed to be subtracting and subtracting the ones I'm supposed to be adding. So that'll give me the wrong result. Cool. Then from here, I can say powSum plus equals num to the IDX, and then IDX is just the opposite of that. IDX sum is just the opposite of that, I mean. So IDX sum plus equals IDX to the num, and for the first one I should get 4, 4, 3, 3, 0, and 66282, and the second one I should get 0, 4, and 10. So 4, 4, 3, 3, 0, 6, 6, 2, 8, 2, and 0, 4, and 10. Good. Looks like it's working. Does this... let me know if this is helpful. Oh, I'm sorry, and you have code posted. Let me go through and look at your code too and kind of try to get a sense of how you're thinking about this. I believe this is exactly the same. Yeah, just flattened those conditions, but that's the same code that I had before. Sometimes I'll come back and solve these. I always save my old, kind of hoard my old solutions because it's interesting for me to see that sometimes sometimes I'll take different approaches to solving the problems. I get to see like a history of the solutions. But anyways, let me go through the code that was posted alongside of this and see if I can find where the issue is. Apologies, I do usually try to do that as my sort of first thing, but I honestly just spaced. Okay, put that there. Okay. One thing I see is a 2-space indent, which I'm going to need to fix. This is actually valid code. It right here. This is a 2-space indent. I'm going to assume that you're working out of Replit. Replit defaults to a 2-space indent. If you go on the left-hand side of Replit, there's a column of icons. The second from the bottom now is an icon that says Settings. If you go click on Settings, it's a gear-shaped icon that says Settings. Click on that, and a little past halfway down, there's an option that says Indent Size, and you change that from 2 to 4. For some reason, Replit defaults to 2. In every other language, well, most other languages are not white space formatted like Python is. So you can use 2-space formatting with Python, although it's not conventional. I'm not going to put anybody at fault for doing this because Replit defaults to that, and that's fine. But since I'm set up for a 4-space indent in my text editor, I need to kind of rectify this manually. So just give me a moment to do that. So I'm starting with the innermost parts first, and I already see what I think. Yeah, I already see the issue, which is going to be that there's a lot of returns happening that don't need to be happening. Okay, excuse me. Almost done. Oh. Okay. So I believe this is just the 4-space indented version of what you were returning, or the code that you sent me. Okay. So let's walk through this. So since I see a lot of returns here, there's something about a return when your code, when your function encounters a return, it stops executing code. So it's finished. So what's going to happen here is we have for num and index and enumerate num list. If index mod 2 is 0, so if index is even, we set, and 0 mod 2 is 0, then we'll set evens equal to the sum of num list plus num, and then return evens, and then no other code is executed. So this code currently will make it to this point, and then the rest of this never even gets evaluated by the interpreter. And we can prove this. Print hey. So if we don't see that hey, we know it's never going to make it to this point, and it won't. We can see, well, let's do this as well if we run that. Okay. List 1 is not defined. Let's do, I'll just copy these tests here. Same diff. So it looks like, oh, so I was wrong. I guess this will execute the second time. Let me check this. Yeah, okay. So this other one will run. So we'll make it past this condition once. So I would expect to see this printed out as many times as this loop is going to run, right? So we could also print out. Oh, well that's another problem. Enumerate return gives back the index IDX, then the number. I always find it more intuitive that enumerate should return the number and then the index, but it doesn't. It's always index first, then the element from the object being enumerated. So that's one issue. So let's print out the IDX, and this will actually tell me how many times the loop executes. Hmm? 0 and 22. Oh, right. This is returning 22. That's what's happening. So 0 is the first iteration, and it doesn't make it past that in this case. So basically what we have to do, the idea is that we want to return this specific thing. So we'll do that at the end here. And we can just get rid of these other returns since they're going to prevent our loop from continuing to execute. So this is if it's even or odd. The sum num lists, I'm reading this as like take the current value of evens or odds or whatever and set it equal to that. Although we need our targets, our accumulation targets. So I would do this right directly on alt sum, and then do that, right? So alt sum equals alt sum plus num, or alt sum equals alt sum minus num, right? Now, one thing here, since there are only two, for a given value of index over 2, there are only two possible remainders, which is 0 or 1. It's going to be even or odd. So necessarily, since this is literally the negative case of the previous condition, we can just call this else. And that'll kind of cinch things up a little bit. And we'll get rid of that one. And then, yeah, so you have these other two loops where you're constructing powsum and idx sum. So we'll just do plus equals there and plus equals here. And the sum function only takes in a it takes in a list or a tuple of numbers, and it returns the sum of all those numbers. So that can be a little bit of a weird one. Okay, so this will work, although we have these other two for loops that are looping through the same thing, which means we can just get rid of those for loops and just do these operations in line. And I mean, basically, this is the code that I wound up with. So yeah, you had a lot of good. You're chasing down a lot of good leads, but just needed kind of a little bit of help at a couple places. So cool. Oh, cool. Good on changing the indentation size. Yeah, that's I wish they would. I mean, for every other language, I kind of like a two-space indent in like JavaScript. If I code in JavaScript, I'll often use a two-space indent because it's really common. But JavaScript, it doesn't matter because JavaScript is bracket formatted, so you can literally do whatever sloppy, inconsistent, or alternate spacing style that you do, and it'll be valid code. You shouldn't do, you should still stick to a consistent, careful, indentation guide, whether you're doing 2 or 4, or there's some coding styles that do like a 3 or a 6 space indent, which is, I think, it's really weird, but it's out there, like you can pick whichever style you want. And in JavaScript, it's like, hey, white space doesn't matter, so just as long as you're being consistent enough that the code is readable, you use whatever standard you want. And most languages are bracket formatted, like JavaScript. But since Python's white space formatted, you can do something different. Like I said, it will be valid, but it's a lot more of it's a much bigger change, to change the spacing in a language that's white space formatted. I'll work with people a lot that'll be on a 2-space indent in Replit, and we'll be working in the same REPL, and they'll be doing 2-space indented code, and I'll be doing 4-space indented code. And basically what it means is that our code is not compatible unless they double indent. So I always have people change that. So anyways, ramble complete. We have another question here. Will the code run? Whoa. Will the code after the return run? So if the return line is executed, no further code will be executed. No, including if you're in the middle of a loop, if you're going to loop through 10 items, and at some point you run a return line at the third element, it stops. It doesn't even continue with the rest of the loops. It's over. So cool. Indentation in JS seems more natural. Specifically, I suppose you're referring to bracket formatting versus white space formatting. That's how I'm taking that. But yeah, I mean, people definitely have a preference of one over the other. I think white space formatting is like visually prettier, although it essentially you end up with something that is necessarily like stricter. Like the Python interpreter is like, you better do it correctly, otherwise it's not going to know what you mean. I think the side effect of that though is once you get the hang of it, code looks really consistent. Code, like your code and my code will, it's hard not to impart your own style somehow, which is fine. But the way I write a solution, if I implement the same, sort of logical steps as you are, we might have different variable names, we might have different little eccentricities that are sort of unique to our own coding styles and personal coding styles, but structurally the code will look and read basically the same. So I think that's actually a really nice feature of white space formatting. Oh, you're saying it feels more natural to do 2 spaces as opposed to 4. Yeah, I like it in JavaScript. I got used to that in JavaScript, and I will say that I like it. But in Python, I think it can, since like and maybe this is because I'm dyslexic, but since your visual cue for what's indented, or for what is a member of what is indentation, it's just like, to me visually it's a more obvious thing with 4 spaces, whereas 2 in Python can feel a little muddy because you don't have those brackets saying like, okay, this ends here because there's an ending bracket or something. So yeah, anyways, quite agree. All right, yeah, well, I don't see any other requests for a question as of yet. Oh, somebody's saying we got they have a few more questions, but don't want to dominate. Well, that's kind of you. Yeah, I mean, we'll open up the floor to anybody who's got any questions. But yeah, I think you're it at the moment. Feel free to post them in. Otherwise, I'm just going to go through to the next lesson after unpacking lists, the append method. I'll just queue this up for now. Yeah, somebody saying that they prefer braces to indentation, but recognize how each language has their own things going for them. Yeah, totally. I always thought it would be cool to have, because I really do prefer white space formatting, but there are times when I miss bracket formatting. It's like, it's sort of like for day-to-day coding, like brackets kind of feel like extra and they kind of feel messy. It's nice to just have like really clean, pretty white space formatted code for me. But there are times when like you have sort of deeply nested things and you have like really things are starting to get convoluted, and it's nice to have that explicitness of brackets. But I always thought it would be cool to have a language that was like white space formatting where you could use brackets, and if you use brackets, you just have bracket formatting rules. And you could use those for the times where you wanted to be explicit, or for the people, and there's a lot of people who prefer bracket formatting. Like if you preferred bracket formatting, you just do bracket formatting. So I don't know. I think a lot about this particular thing. Yeah. Anyways, I'm enjoying nerding out about this. Thank you. All right. Cool. We've got our other question posted. I'm waiting for Slack to load here. Someday it'll load. Okay, here we go. Oh, is Ruby like that? Ruby is one of the... God, I don't know if I've... No, I did write a little bit of... I downloaded and installed a Ruby interpreter for a project, just a school project, and the project was basically to install Ruby and like write hello world. That's all I've ever done in Ruby. But I didn't know that Ruby was like that. That's interesting. So I think it's like the only sort of major language left that I haven't actually tried to like really do anything with. 1 second here. I'm getting a call. Okay. What is an accumulator? Oops. Accumulators in question 3. Okay. Let's go to question 3. What is an accumulator? Did I complete this one? I did. Okay. Complete the accumulate function below according to its docstring. Oops. Well, try to hide my solution there. So the accumulator pattern, while we're here, every time the accumulator pattern comes up, I sort of talk about its importance. Because it's kind of funny. Like when I was learning programming, they're like, here's the accumulator pattern. We'd have like a topic on, and our material is presented like this, and it's a challenge to like, it's a challenge in Learn, in writing our material and Learn to emphasize things appropriately, right? Like we just did a lesson on unpacking lists, and now here's another lesson on accumulators, right? In terms of like, unpack. I mean, it's good to know how to unpack lists and tuples. It's, but it's not like the central theme of programming that accumulator patterns often are. Accumulator patterns are not the only thing that you do with programming, but there are times when it feels like it. Like you'll have days of coding where at some point you'll realize, like, or I had this realization, and other people have, but it depends on the kind of coding that you're doing. But you may at some point realize, you may at some point have the thought like, I just spent the last 3 days like writing functions with accumulator patterns in them almost exclusively, like over and over again. So there's a lot you can do with an accumulator pattern. That's an important thing. And there's obviously a wide variety of accumulator patterns. But I would say it's basically a simple system that has a number of elements that can be combined in a small number of let's say a small number of elements that can be combined in novel and kind of creative ways. You can get pretty creative with an accumulator pattern. It's pretty there's sort of a general form, and then there's a pretty broad way of implementing the various things you can do with that. Okay, I think I've made my point. All right, so accumulate returns an object that is the accumulated result of chars. Chars is a list of characters, returns a string. Okay, so I think I can cheat here. I like it when I can cheat on the solutions because I guess I like to cheat. I don't know. Maybe I should see a therapist for that. I'm just going to see if this is going to work. No, okay. Cheating failed. Yep. So we have this list of characters, and we'll just say, I'm not even going to bother writing a test for this. Well, no, I should. I put so much emphasis on it. I'm like, now remember, start with your tests and work backwards from there. So I'll do it. Okay. H E O O. Okay. So many keystrokes. Okay. So now we have a list of characters that says hello world. I could have just cast that as a list and it would have been fine. So what I want to do here is just say, I'm going to start my accumulator string. I'm just going to call it ACC. We'll have an empty string. And I'll say for character in chars, which is my list. We'll say ACC and we'll concatenate. So ACC equals ACC plus C, or chars, excuse me, plus CH. And then we'll return ACC. And that's all that this one is asking for. So it's a real simple one. Syntactic sugar, a little bit of syntactic sugar. We can do plus equals, and that translates into ACC equals ACC plus CH. And I'm sure that this is the solution that I had before. Yep. Run that. So I think the difficulty with this one is the sort of the simplicity. That it's sort of just a very straightforward small problem, and it might seem like it's asking for something bigger. Something worth noting here, the accumulator, there's sort of various, we think about accumulators as being related to the type being accumulated on. I'll often call that the target. So in this case, the target is ACC, which is a string. ACC is a string. So string accumulation often happens with slicing, indexing, and concatenation. So those are your tools for altering strings. And I like the I like that way of doing things. Like getting comfortable with concatenating, slicing, and indexing is those are really good tools. So in this case, all we needed to do was just concatenate. Cool. All right, I'm not seeing another question yet. Let me know if that was helpful, if you have further questions. Does the accumulator kind of work like append? Yeah, so the plus equals, so that's a good question. I mean, you might even ask the question, well, why not just append, right? So this has a similar behavior. However, the append method, this particular thing, writing dot append after something, only applies if the thing you're calling it on is a list. Right, so we can only append to a list, whereas plus equals works the same. It's the analogy for append for strings and tuples. You can actually do a plus equals with a list too, and it will work exactly like append does. Which I found out the other day that it doesn't make a copy of a list if you do that. sorry, I'm adding additional information at this point. The answer to your question is the plus equals is the analogy to an append for a string. Cool. Oops. There we go. Cool. Glad that was helpful. Anybody got another one? I'll give us a couple seconds before I jump into the material. Don't be shy. I mean, you know, that's useful about the study halls is being able to go through people's questions. So. Cool. We got another one. Question 3. All right. Just fighting Slack features. Oops, not there. Having trouble with the filtering. You want me to go through your code? If you want me to go through your code, send it in, and I'll do that first this time, rather than do the solution. Okay. I'm not seeing the code come in. Oh, we gotta hang on. Okay, I will wait. Cool. Here we go. Let me copy this in. Okay, so our goal is sum up only the odd integers from mixed data using an accumulator variable called oddsum. Okay, so oddsum equals 0. That's good. For num in mixed data. Oh, and you got your indent fixed. Nicely done. That makes it easy. So for num in mixed data, if is instance. Okay. We have this thing about is instance in our material. There might even be something that says like you should use is instance over type. So no worries. I don't know why. There's probably a good reason for this. This happens occasionally where I'm like, why does this exist? And then, you know, the Python developers are smart people. They're building a whole programming language. So they usually have good reasons for doing what they do. I cannot discern why this function exists. I don't know the purpose of it. What I prefer to do, so I don't mean to chastise you at all, because I know we have this in our material. And I think it's maybe worth having so people know you'll see it out there. So, yeah, anyways. I prefer to use type. So we'll say if type num, and then what did we want to do? Only the odd integers. So if type num equals int, that's the case that we want to add it, right? So if it's number one, if the type is an integer, and number two, if num is odd. So that's mod 2 equals 1. Excuse me. Okay, so we have two conditions for this one. Oops, I have this if, that second if. Apologies, that doesn't belong there. So and num equals this. So only one if is necessary. That second if was an error on my part. So if this condition, which is that the type of the number is equal to an integer, and this condition are true, which is that the number is odd, then we'll add it. So let's just see what this is. $92. I don't know. That seems like a reasonable explanation? X plus something. Expectation, that's the word. Okay, so let's see. Oh, I'll just comment out my solution there. I think it's probably the same. Oh yeah, I nested the conditions, which is a sort of a de facto and. But yeah. I got is instance in there. I want to go through and maybe sort of emphasize that thing on is instance. I find type just, there are certain cases where is instance actually has some pretty unexpected behavior. There's some places where it doesn't behave like type does. And I think that type has, to me, more intuitive behavior, but I don't know. Yeah. No, the indentation looked good this time. I don't know if it did it automatically or something, but yeah, it was fine. Cool. All right. Any questions about this? Feel free if you got any questions about this solution. Go ahead and ask. I'm not seeing anything yet, but floor is open for that. So. Cool. Okay, I'm not seeing anything. That's okay though. Cool. You're welcome. Glad that was helpful. You know, I just threw this thing out here about is instance, and now I feel like it's sort of my responsibility to justify my position rather than, I hate just, throwing you something and saying, oh, just take my word for it. I mean, sometimes it's, for the sake of brevity, maybe what we need to do. But, since I mentioned it, maybe I'll just go through this thing about is instance. So, is instance is a way of doing type checking. I think the sort of the selling point of it, the thing that it, I guess, does supposedly that type doesn't do, but you can do it with type, and I'll show you, is you can see if something is an instance of a multiple other types, right? So say if is instance, the first argument will be the thing that we're wondering about, is it an instance of, and I think the second, I think we can take any number of arguments. So let's just say num equals we'll do this, nums. We'll make a list. I'll put it in a for loop. So we'll have an integer, a float, and a string, and another integer. Okay, so if for num and nums, if num is an instance of int or float, and I honestly might have the syntax on this a little bit wrong, but we'll print num squared. I'll fix it if it gives me an error. Two arguments. So I think maybe the second needs to be a tuple or a list. Yeah, okay. So the idea is that I can say if the type of this thing is one of the other thing, and you pass it like a list or tuple of other types that you want. The thing is, you can do this with, there isn't a reason this behavior exists with type. You can say if type num in, and you can do a check for membership, and we'll just do a tuple of int comma float. This is a shorter line of code too. Not that that matters at all. I mean, line of code needs to be as long as it needs to be, but it is. It's a little more concise. I think it reads better if the type of the number is a member of the tuple int and float. So if it's one of these, to me this just says if the type is one of these, then print num squared, right? So this behavior works. So whether you're checking one thing, you could say if it's maybe you only want to do this if it's equal to an int. You check one thing, you can say equals like this. I mean, you could do a tuple with a single element in it also, if you wanted. Something like that. Or just check if it's equal to this. Maybe you don't know that you're trying to check an int and you want to do some sort of other dynamic type checky thing where you have like a equals some data, and you don't know necessarily the type of a. Well, you could just do type a. Right, so if the type of the num is equal to the type of a, then do this. And if you used isInstance, you'd have to do if num is instance of type a, and does this have to be a tuple? Right, so you still have to use type in here anyways, right? Like, so it's not even saving you, I don't know, it's not even saving you the use of type as a function. So I can't see a reason for this to exist. Not that there isn't one, if it's just that if it is, I don't know. For type star star. Huh. This is true for some reason. That's not even. Yeah, see, like that like this should be false. In my mind, this should be false, but like the behavior of isInstance is not always predictable to me. Okay, wow. It's unique. Let's try that. — 133. Between string and int. Did I? Oh, right. No, that should be true because it's going to be true there, right? Right, so I just wrote broken code. Well, anyways. It wasn't isInstance's fault. That was my fault. Okay, so that's one thing. Another thing about isInstance is if I said, let me kind of blow this example away because this is getting weird. So if I said, we'll do this. Make a copy. Okay, there we go. So notice I have no Boolean values in here. So if I said the type of num is equal to bool, let's just print num, just right. So nothing, our code ran, but nothing happened because, none of these are equal to Boolean values. This should, hopefully this is pretty expected behavior. If the type of one of these elements is equal to a bool, do this. There's no bool, so this should continue to be false. I believe if we use isInstance, I believe it'll consider these the same. Maybe it's the other way around. I think it's the other way around. So we'll say if true, int yes. So this is saying if some Boolean, this is actually considering this Boolean value to be an instance of all of these, which is weird. So this kind of behavior is, I mean, I understand why it's doing this, but it's not what I would expect. So to me, I don't know. My opinion, isInstance is kind of a confusing one. I think type is easier. It's a simple tool that has easily anticipated results. So feel free to, you may disagree, and you might know of a good, use case for isInstance, some use case that it covers that type doesn't, but yeah. Anyways, just wanted to qualify that so it wasn't just hanging out there, not just taking my word for it. Cool. Also, again, not trying to like chastise anybody for like using isInstance, especially like when it's in our material and we're telling people to use it. So I'm just opining, I suppose. All right. Cool. So I'm going to move on. I don't see any other questions. So we'll go on to the append method. This will be a pretty quick one. Some folks already were asking about this. So append applies to lists only. You can concatenate in such a way to strings and tuples. You can concatenate onto strings and tuples and actually lists in such a way that like kind of mimics the behavior of append. But append is a mutable operation, meaning it changes the value on the level of the list, not on the level of the variable, which is what happens with concatenation in strings and tuples. And I kind of went over some examples of that when we were talking about mutability. I think that was last study hall, 1 or 2 study halls ago. So yeah, append its only job is to put an element on the end of, or on the right hand side, the end of the list. So yeah, that's something that's just worth remembering. It does not. It's also worth mentioning that it does not have a return value. I'll see people do this thing, and I get this. Like, I get where this is coming from. List equals empty list for num in nums list. Where's my nums list? I'll just make a nums list. So I'll see people do this thing where they'll say list equals list dot append. This is going to be weird. This is going to have a weird behavior because the returned, quote unquote, returned value of append is the value none, not the list with the appended value, right? So append is not useful for this. I'm trying to think of how to demonstrate this. Well, you're going to see this work once. Actually, let's do this. So here's the value. Let's see if I can show this. Okay, so it's a little confusing here, but we have this empty list, which is this first one. Let's just number these prints. We'll call this 1. We'll call this other one 2. Okay. So the first time list is an empty list, then number 2 is list is none, and then we get another iteration. So it goes up to this first one again because the loop starts over, on to the next iteration, and it's none again, and then we try to append to none, and then we get an error. It says attribution error. None type object has no attribute append. So this is a weird one. So you don't want to override the value in this way. You just call append. We're just going to see duplicate versions of the list. Yeah. So 1 is an empty list, then 2 is a list with 4 in it, 1 is a list with 4 in it, then 2 is a list with 4 and 5, etc., right? So we're seeing these double instances because I'm printing it off. So that's something that's worth remembering. So you don't really like assign, something to an append in that way. You just call the append and it causes the mutation in the list itself. So cool. Let's just do these. These will be quick. In the code below, list is declared as a list of 4 integers. Append any object to the list and submit your code. List.append. Hello. Oops, I hit save. I don't want to save. I want to run. Okay. What will be the value of the list after the following code runs? This is a list. This is my list, and we append another list. So we're appending. So I forgot to mention this, but this is worth mentioning. append can only append one item. This is valid code and it'll execute, but it appends the whole list. It doesn't append each of these elements individually. It just appends the entire list. Okay, so now it is longer. So we need a list. This is my list with a list of now this is longer, so that's going to be the second option here. Okay. Have some actual code to write. That'll be good. Okay, write a function called Append3 Elements. So we have our list, and we'll say, I'm just going to call these A, B, and C. The first is a list called list that you will be appending to. The next three parameters will be objects that need to be added to the list, A, B, and C respectively. Oh, that's what I called them. This function should return a new list with the 3 elements appended at the end. So it should be a different list. So we're not going to be altering the original list. So I'm going to do this. This is going to show us if we're altering the mylist variable. So we'll say list equals list.copy. So I'm just going to copy it right out of the gate so I don't alter the mylist variable. And I'll do this again where I will alter this, and you'll see why it's good to do it this way. Okay, so at the end of this, my list should be empty. So we'll say list.append A, B, and C, and then return list. So the first one is the list that was returned, and the second one is the original list. So this is desirable behavior for when you have a function that takes in a mutable data type such as a list or a dictionary, that it does not alter its inputs. So it never mutates its inputs. I always feel like putting a caveat when I say that. There are times when maybe you want to do that. Honestly, you might want to break that rule sometimes, but you do so like knowing full well what you're doing. And if I were going to do something like that, I would rename the function. If I was naming the function, I would personally I would name it something like mutable append3 elements, and I would put something in the doc string. I'd probably put it first thing in the doc string, like this will make it mutable. If I don't do this copy, it'll make it mutable. So what I would do is warning, this function mutates its argument list. And then I would describe in what way it mutates it. So I would make it very clear what was happening. I don't think I've ever actually done this on purpose, other than to just like demonstrate it. But you can do it by accident really easily. So notice I'm getting 2 instances of the same list, and that's because my list comes into here, and since I didn't copy it, it literally alters my list. It literally alters the my list variable. So it alters the variable that I passed, and in this case, this is undesirable behavior in general. Like I said, perhaps you could find an instance where this might be necessary, and there genuinely may be one, but it's to be avoided if at all possible, and in my experience, that's possible. But your experience may differ. So at least I believe all of the material in Learn at this point is will sort of have you avoid that, unless it's sort of demonstrating like, hey, what happens if you don't avoid that? So something to look out for there. Cool. Oops. May do list.copy. List equals list.copy. So let me copy this and submit it. Paste it in and submit it. See if that works. Yay. Lovely. So same code. Copy, append. Suppose we could be fancy if we wanted to. Just do a variation on this for L in A, B, C. You just make a tuple out of these. List.append L. Slight variation there. Same code. Okay, cool. Well, this puts us right about at time. This is our usual, close to our usual stopping time. We've got about a minute left. So I think I'll wrap up here. I'm not seeing any other questions. If you have any other questions, feel free to DM me. I apologize. I know I can take a little bit of time to get back to folks, but things are kind of slowish right now, so I should be able to get back to you fairly quickly, within a day or two. That seems like my turnaround at this point. But yeah, do feel free to message me and reach out. I'm free. I have a lot of availability for one-on-one mentoring. If you want to meet one-on-one, we can schedule an hour at some point in the week. If you're viewing this not as a Galvanize student yet, you can just go join we have links in the description to where you can join our basic prep channel, and you can reach out to me there or one of the other instructors, and we're happy to help. Don't be a stranger. We'd love to hear from you. Please do feel free to share any constructive criticism. Obviously, please be polite. I would appreciate that. One thing that comes up occasionally is the resolution on the streams is kind of low. This is an issue that I am aware of, and it's a stopgap that's helping the streams like be intelligible for now. Unfortunately, so the low resolution is intentional, but I'm getting a better computer that I think will be able to handle the streaming a lot better and be able to stream in a higher resolution. So improvements in that regard shall come soon. But yeah, do reach out. Let me know if you have any ideas, ways we can improve, and be happy to consider them. Yeah, cool. So this was a lot of fun. Thanks to everybody who participated. I do appreciate that. And I look forward to seeing y'all for next study hall on Friday. Cool. Yeah, see you then. Bye-bye.